Hello! Today we delve into the details of some of the most interesting blockchain project exploits. Each case provides invaluable lessons for developers, investors, and the wider blockchain community. By revisiting these cases and discussing them, my intention is not to undermine your confidence in blockchain technology, quite the opposite. The open source nature of the Web3 world and its open-minded community provide us with a unique opportunity to learn directly from past mistakes and avoid repeating them. Understanding the history of these incidents makes development more resilient and highlights the significant impact even a small error can make. The case I want to start with is the DAO hack that happened in June 2016 because of a vulnerability in smart contract logic. The Decentralized Autonomous Organization, DAO, was an ambitious Ethereum-based investment fund. Launched in 2016, it raised over $150 million in Ethereum from investors. It was designed to allow investors to vote on which blockchain project should receive funding. The DAO was meant to operate without a central authority, using smart contracts to manage funds and decisions. Investors could buy DAO tokens with Ether to gain voting rights and a share of future profits. However, a critical vulnerability in its smart contract code allowed an attacker to drain 3.6 million ETH, worth approximately $60 million at the time. The attacker exploited a flaw in the DAO's withdraw function and performed a reentrancy attack. When someone withdrew their share, the contract was supposed to first reduce the balance of the requester, then send the Ether. However, by recursively calling the function before the contract could update balances, the attacker siphoned funds repeatedly in a single transaction to a child DAO controlled by him. But the stolen ETH could not be cashed out immediately because the child DAO had a 28-day waiting period before funds could be moved. This gave the Ethereum community time to react. There was widespread debate on how to handle the situation. An initial proposal was to implement a soft fork to blacklist transactions from the attacker. This was seen as less intrusive but didn't solve the underlying issue of the funds already moved. The more contentious but ultimately chosen solution was a hard fork to essentially reset the Ethereum blockchain to a point before the attack, moving the stolen funds back into a new contract from which they could be withdrawn by their rightful owners. The hard fork resulted in two versions of Ethereum. Ethereum Classic. Those who opposed the fork continued with the original unaltered blockchain, arguing that code is law and that the hack should stand as an immutable part of the blockchain's history. Ethereum Classic maintained the principle that the blockchain should not be altered post factum. And Ethereum, which was the new chain where the DAO funds were returned to their owners. This chain is what we commonly refer to as Ethereum today. By the way, what would you choose? To return the stolen money but reverse transactions history, or leave as it is even if the stolen money is stuck on the hacker's wallet? The hard fork was implemented on 20th of July 2016 and involved rewriting the blockchain's history to move the funds back to new withdraw DAO contract and allowing token holders to withdraw their ETH from this contract. The hacker, or whoever held funds on the Ethereum Classic chain, retained a significant amount of ETH, which remained valuable as ETC. At some point, these funds were moved, with reports indicating that around 5 million worth of ETC was moved in 2016, suggesting the hacker might have been attempting to cash out or move the assets discreetly. There is no definitive public record of how much, if any, of the stolen funds were utilized or recovered in a legal sense. So, what about the attacker? In February 2022, journalist Laura Shin named Toby Hornish as the likely perpetrator behind the DAO hack in her book The Cryptopians and in an accompanying Forbes article. Hornish, an Austrian programmer known for co-founding 10x, was implicated through a trial of transactions analyzed with blockchain forensic tools like those from Chainalysis. As Laura Shin stated in her Forbes article, investigators tracked the presumed attacker's activity, demixed the Wasabi transactions, and discovered that the funds were swapped for the privacy coin Green and withdrawn to a Green node called green.toby.ai. From there, it was not difficult to conclude that the person behind this domain name was Toby Hornish, who used the handle @TobyAI across multiple social media platforms, including his email address. His location aligned with the cash-out activity, which primarily took place between 8 a.m. and 11 p.m. Singapore time. The presumed motive was that his warnings about the DAO's technical vulnerabilities were not taken seriously enough by its creators. While Toby Hornish was publicly named as the suspected hacker, there has been no legal resolution or official punishment directly linked to the hack. The DAO hack remains a pivotal moment in blockchain history, teaching the community about the critical importance of security in smart contract design and the broader implications of blockchain technology's governance and philosophy. Parity Technologies developed a multi-signature wallet for Ethereum, which allowed users to manage their Ether securely by requiring multiple keys to authorize transactions. However, a vulnerability in the smart contract code led to these two significant breaches. The first incident happened in July 2017, where funds were stolen, and the second, more severe incident where funds were locked happened in November 2017. During the July 2017 incident, a flaw in the wallet smart contract allowed an attacker to exploit a function that was meant for adding a new owner to the wallet. The vulnerability was due to an integer underflow in the function's implementation. Specifically, the function used to manage wallet ownership had a check to ensure that the number of owners did not exceed a certain limit. However, due to the underflow vulnerability, when the number of owners was 0, subtracting 1 could wrap around to the maximum integer value, effectively bypassing this check. An attacker exploited this to become the sole owner of multiple wallets, subsequently draining around $30 million worth of Ether from several wallets. What's interesting that there was a white hat hacker group that used the same exploit to drain money and save the rest from this black hat hacker. And they were able to save over 377,000 of Ethereum, while 44,000 were lost. And looking at the address that drained those 44,000 of Ethereum, we can see that actually he's still active, doing transactions 35 days ago and 17 days ago. And if we look at the first transactions, how it all started, we will see that the first transaction was injecting money to this account a day before the theft. And there were multiple transactions of 10,000 of Ethereum being transferred. As a result, Parity issued an upgrade to the wallet software, urging users to update their contracts. There was no rollback or hard fork to undo the theft, but Parity offered assistance to the affected users, including a bounty program for returning stolen funds. The hacker has not been publicly identified, and shortly after the hack, the stolen ether started moving, with reports of the hacker attempting to launder the funds through various exchanges like Changelly, Shapeshift, and Changer. In January 2021, some of the stolen ether converted to RAN BTC was moved, suggesting the hacker was still active and attempting to cash out. However, much of the ether remained untouched in wallets associated with the hack. There was another significant movement in May 2024, where the hacker began laundering 3,050 ether, worth about $9 million at the time, through the exchange, indicating that after years of dormancy, there was still interest in cashing out these assets. And we are moving on to the November 2017 incident, which was even more devastating due to another vulnerability in the wallet's library contract. It directly affected Polkadot, as approximately 60% of the funds raised during Polkadot's ICO, which was around $140 million, was stored in multi-signature Parity wallets that got locked due to the bug. This meant that a significant portion of Polkadot's treasury was unacceptable for a period, potentially hampering project development and operations. It's like raising investments for building a skyscraper, but having access only to 40% of that money. Here's what happened. A user accidentally called the init wallet function on the library contract instead of the wallet instance. The function was not meant to be public, but was due to an oversight in the code. This call made the library contract think it was initializing a new wallet, but instead it overrode the library's own state, including setting its own SRA to an empty list. This action effectively made the library contract believe that it was a wallet with no owners, which then led to the contract's self-destruct feature being triggered. Self-destruct is a function in Ethereum smart contracts that can delete the contracts from the blockchain, sending any remaining ETH to a specified address. Since there were no owners, the contract was deleted, and all wallets using this library lost the ability to transact, locking over $150 million worth of Ether at the time. This incident is considered to be more of an accidental activation by a GitHub user named DevOps199, who acknowledged the mistake publicly on GitHub. People believe this was not a case of malicious hacking, but rather a user inadvertently triggering a bug that led to locking funds rather than stealing them. Therefore, no legal action was taken against DevOps199. Parity Technologies and the Ethereum community discussed various recovery methods, including hard forks, but none were implemented. The funds remain locked on the blockchain, essentially lost. The Parity Wallet Bug serves as a stark reminder on how even seemingly minor oversights in smart contract code can lead to significant financial losses or operational issues in blockchain systems. On February 2, 2022, the Wormhole breach, a cross-chain protocol linking Ethereum and Solana, was exploited for $325 million in Ether, making it one of the largest exploits in DeFi history. This incident underscored the challenges of securing cross-chain systems. The bridge allows users to lock assets on one blockchain and mint equivalent wrapped assets in another. For example, depositing Ether on Ethereum lets you mint wrapped Ether on Solana. A bug in the Wormhole contract Solana side verification mechanism failed to correctly validate signatures from the guardians, the entities that verify and sign cross-chain transactions, enabling unauthorized transactions and allowing the attacker to forge signatures and mint wrapped Ether on Solana without actually locking Ether on Ethereum. The hacker minted 120,000 wrapped Ether on Solana and swapped them to other assets, effectively laundering the stolen funds. Wormhole took immediate actions and paused the breach, temporarily disabling the functionality to prevent further exploitation. The protocol offered a $10 million bounty for the return of the funds, which the attacker ignored. Jump Crypto, a key backer of Wormhole, injected 120,000 Ether into the protocol to maintain solvency and protect users. The Wormhole team patched the vulnerability and redeployed the smart contract. Users were reassured by the rapid fund replenishment, but trust in cross-chain bridges was damaged. Meanwhile, after minting 120 wrapped ETH on Solana and bridging almost 94,000 ETH to Ethereum, the funds stayed dormant for nearly a year, until 14th of January 2023, when the exploiter resumed activity, shifting millions across Solana and Ethereum using multiple wallets, swaps and bridges. During only several hours on 14th of January and 23rd of January 2023, by converting assets into Lido-staked ETH and leveraging DeFi protocols, the hacker maximized anonymity and liquidity while securing loans against stolen funds. The question remains, what's his next move? Here are some key lessons for developers after exploring this case. Use cryptographic algorithms that are resistant to forgery, as well as implement multi-layer checks for signature validation. Use multiple independent oracles or validators to minimize single points of failure. Conduct security audits to identify and patch vulnerabilities. And perform stress tests simulating edge cases, including malicious inputs. Deploy automated systems to detect and flag anomalous activity such as unauthorized minting or large withdrawals. Communicate openly with the community during incidents and act swiftly to patch vulnerabilities and secure funds. And when it seemed everyone forgot about this case, it reminded itself during the airdrop in April 2024, when Wormhole announced a significant airdrop of its native W token to early users and participants in the Wormhole ecosystem. Wormhole forgot to exclude the exploiter from the airdrop. During the initial setup of the airdrop, 4 wallet addresses associated with the 2022 exploit were mistakenly included in the eligible to claim around 31,642 W tokens, which would have been worth approximately $50,000 at the time. But the good news is that the incident didn't result in the hacker receiving any tokens, since their eligibility was revoked before any tokens could be claimed. The Wormhole hack remains a pivotal case study for blockchain developers, emphasizing the importance of thorough security measures in building robust, scalable, and trustable decentralized solutions. The target of the next attack I'm going to talk about was the Ronin network, which serves as a blockchain for the popular play-to-earn game Axie Infinity. Specifically, the attack focused on the Ronin breach, a system that allows users to transfer assets between Ronin and other blockchains like Ethereum. Approximately $625 million in cryptocurrency was stolen in March 2022. The hackers managed to compromise 4 out of the 9 validator nodes run by Sky Mavis, the company behind Axie Infinity, and 1 validator run by Axie DAO. They found a backdoor through a gas-free RPC node, which was exploited to obtain the necessary signatures for transaction validation. This was a critical vulnerability since any 5 out of 9 signatures were needed to approve a deposit or withdrawal. And with such control, the attackers forged fake withdrawals. The hack went unannounced for 6 days, only being discovered when a user couldn't withdraw Ether from the breach. There were reports suggesting the initial breach might have involved a sophisticated phishing attack where an employee was tricked into downloading malware via a fake job offer PDF, leading to the compromise of internal systems. And it was possible because the network's structure was not as decentralized as it should have been, with Sky Mavis controlling 4 out of 9 validators, making it easier for attackers to achieve the necessary majority for transaction validation. Let's think, how could this attack have been prevented? First of all, decentralization. As it was mentioned earlier, ensuring validators are more spread out among different entities to avoid central points of failure. As well as better practices could be used for managing and storing private keys, potentially using hardware security modules or more robust multi-signature schemes. Conducting thorough and regular security audits, especially after significant updates and changes to the infrastructure. Also, implementing real-time monitoring systems to detect unusual activities or transactions much sooner than 6 days after the event should have helped. So, what happened after the attack was recognized? Ronin breach was paused to prevent further theft, while Sky Mavis worked on enhancing the security of the network, including increasing validator numbers from 5 to 8 out of 9, and improving the overall structure to prevent future attacks. And Sky Mavis pledged to reimburse all affected users, even if the stolen funds were not recovered. The FBI linked the attack to the North Korean hacker group Lazarus, contributing to international sanctions on addresses associated with the stolen funds. While a significant portion of the stolen funds was laundered, some were tracked down and partially recovered through legal actions and cooperation with exchanges. In August 2024, another incident occurred where white hat hackers exploited a vulnerability but returned the funds, demonstrating the ongoing challenge of securing such systems even after major incidents. This hack serves as a profound lesson in blockchain security, highlighting the importance of robust key management, decentralization, and proactive security measures in infrastructure that deals with significant financial assets. The Nomad breach exploit, which occurred in August 2022, was one of the most chaotic and unusual attacks in the blockchain history, resulting in $190 million in losses. Unlike targeted and sophisticated hacks, this exploit resembled a crowdsourced looting event where multiple users drained funds due to a critical vulnerability in the breach's code. The exploit stemmed from a misconfiguration in a breach's smart contract upgrade. A routine upgrade to the breach contract introduced a bug that allowed attackers to bypass signature verification checks and withdraw funds without proving they owned them. Hackers performed replay attacks, copy-pasting transaction data and submitting it repeatedly, draining funds in small increments. A single attacker discovered the vulnerability and drained funds by forging transactions. Once the exploit became public, other users joined in. Tutorials and guides were shared on social media showing how to execute the exploit step by step, and it quickly snowballed due to the ease of execution. Over $100 million in assets, including Ether, wrapped BTC, USDC, and others, were stolen within hours. This turned into an unprecedented looting event where many opportunistic participants, including non-technical users, drained funds for personal gain. So, how was the case solved? Nomad conducted a comprehensive review of its smart contracts, identified the bug, and implemented fixes to prevent future exploits. Also, the Nomad team worked with blockchain analysis firms, law enforcement agencies, and cybersecurity experts to trace the stolen funds. But the decentralized nature of the exploit, with hundreds of participants, made legal action challenging. Although roughly $36 million, about 20% of the stolen funds, were returned voluntarily by white-hat participants, but a large portion of the funds remains unrecovered, likely moved across decentralized exchanges or through crypto mixes to obscure the origin. Nomad promised to develop a reimbursement plan for users affected by the exploit, though the specifics depended on the ability to recover funds or secure additional funding. To prevent such attacks, smart contract updates should undergo rigorous third-party audits and have an immediate response strategy for vulnerabilities, such as disabling contract functions or freezing funds. The Nomad bridge exploit was a wake-up call for the crypto industry, highlighting the importance of meticulous code security and responsible upgrade practices. And for developers particularly, this incident serves as a crucial case study in avoiding logic errors and planning for worst-case scenarios. The Terra Luna hack refers to a significant depegging event in May 2022, leading to a catastrophic loss of $45 billion in market capitalization, where Terra USD or UST, an algorithmic stablecoin pegged into the US dollar, lost its peg, leading to a dramatic collapse in the value of its sister token Luna. This incident is often described as an attack due to the coordinated actions that led to the depegging. That's why it's in this list. Terra's system relied on an algorithmic balance between Luna and UST. When UST's price deviated from $1, the protocol would burn or mint Luna to adjust the supply to UST. This was supposed to maintain the peg, but failed under extreme market conditions. The initial depegging was facilitated by an attack on Curve Finance's liquidity pool, where large amounts of UST were sold, reducing its price below the peg. Speculative traders shorted Bitcoin knowing that Luna Foundation Guard, or LFG, would sell its Bitcoin reserve to stabilize UST, thus potentially profiting from the BTC price drop. But manipulating the liquidity pool, Curve 3 pool, led to a death spiral of depegging. And LFG's attempt to defend the peg by selling its Bitcoin reserve was insufficient against the scale of the attack. The collapse resulted in over $50 billion in losses for investors and a rapid devaluation of Luna, with the price dropping from around $80 to nearly zero, and UST losing its dollar peg, trading at a fraction of its intended value. The Terra network was temporarily halted to reassess and implement emergency measures. Following the collapse, a new version of the network, Terra 2.0, was proposed and launched, essentially forking the blockchain to create a new Luna token, while the old chain became Terra Classic. And compensation in the form of the Luna tokens was distributed to holders of the Terra Classic and USTC based on the specific snapshots before and after the attack. Prevention measures that could have been taken. A more robust liquidity pool or better mechanisms to manage sudden withdrawals could have potentially mitigated the impact. Implementing features to pause transactions or adjust parameters in real time during such volatile events. The LFG's heavy reliance on Bitcoin as a reserve asset might have been a vulnerability. Diversifying into other stable assets could have provided more resilience. A more sophisticated algorithm for managing the stablecoin peg, possibly with circuit breakers or hard caps on minting burning operations, would have helped. So, after this dramatic collapse of Terra Luna, the crypto market was left reeling. But the story doesn't end there. It was just the beginning of a domino effect, with the help of a series of other events leading to the FTX exchange downfall. But this is another story. Blockchain technology has revolutionized industries with its promise of decentralization and security. However, no system is immune to vulnerabilities, as evidenced by several high-profile attacks from the list above that shook the crypto world. Thanks for watching. Bye.